Hello everyone. In this video, we will learn about how to predict period, block and group of an element. First of all, let's see what are the period, block and group. If we look at this periodic table, there are total 18 vertical lines, and these vertical lines 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. These vertical lines are called the group. And if we see the these are the seven horizontal lines 1, 2, 3, 4, 5, 6 and 7, and these horizontal lines are called the period. Then the vertical lines in the periodic table are the groups, and the horizontal lines in the periodic table are the period. And what are the block? The first and second group, these are called the S block, and group 13 to 18, these are the P block, and group 3 to 12 in the middle of the periodic table, these are the D block, and within the D block, the uh, two type of elements are given below the periodic table, that are lanthanoid and actinoids. These are the F block elements, correct? Then in the periodic table, the vertical lines are the groups, the horizontal lines are the period, and the elements are classified on some basic properties, and these are classified into four blocks, that is S, P, D and F block. Then the main topic is to how to predict the period, block and group of the element that is given. First is the prediction of period. So then how we can predict the period that is given. First of all, we have to write the electronic configuration of that element, and the principal quantum number of the valence shell represent the period of that element to which that is belong. If we take the example of sodium, then the electronic configuration of the sodium is 1s2, 2s2, 2p6 and 3s2. Then the valence shell is this, and the principal quantum number of this is 3. Then the period of the sodium to which this belong is third period. Now take the second example, that is of Fe. If we see the valence shell of Fe, we can write the outermost electronic configuration of Fe as 4s2 3d6 or 3d6 4s2. Then in this, if we take the highest quantum number, that is 4, then the period to which iron belong is fourth period. Okay, then to find the period to which an element belong, just find the highest quantum number in the electronic configuration of that element. Second is the prediction of block, and to predict the block, just write the electronic configuration as we have discussed above, and then just try to find that the last element, the last electron that enter into which cell, the last electron enter into which cell, that represent the block of that element. If we take the example of scandium and nitrogen, in scandium, if we look at the electronic configuration, the last electron enters into D subcell, then the block of scandium will be D. And if we look at the nitrogen, the last electron enters into P subcell, then the block of nitrogen will be P. Okay, now we have discussed two, that is first one is the prediction of period, and second one is prediction of the block. For the prediction of period, just find the highest quantum number in the electronic configuration of that element, and for the block, just find the condition in which the electron enter into the subcell, and the last electron which has entered into the subcell, that will be the block of that element. As we have seen in the scandium, the last electron enters into the d subcell, then the block of scandium is d, and in the case of nitrogen, the last electron enters into the p subcell, then the block of nitrogen is p. Now third is the prediction of the group, and for the prediction of group there are several formula. For the S block, we had find the block by the previous method. Then for S block, the number of valence electron is the representation of the group of that element, and for the P block, then the formula is 10 plus number of valence electron, and for the D block, then there can be used two type of formula. First one is 2 plus number of n minus 1 d electron, or simply we can say the number of valence electrons. Okay, just look once again for the prediction of the block, prediction of the group of that element. For the S block, the number of valence electron will be the group of that element, and for the P block, then the formula is 10 plus number of valence electron, and for the D block, there are two types of formula we can use. First one is 2 plus number of n minus 1 d electron, and second one is number of valence electron. For the D block, the most precisely used formula is number of valence electron. Now take some example to find the number of group. First one is first one is the lithium. Lithium has atomic number 3 and electronic configuration is 1s2 and 2s1. Then in valence cell, or the valency is 1. This is the valence electron. This is a valence cell, and the number of electrons in the valence cell is 1. Then the group for the lithium is 1. Similarly, if we look at the magnesium, then this is the valence cell, and the number of electron present in this cell is the valence electron. Then the group of this element will be 2. Okay. Then we know that aluminum and chlorine are in the P block. Okay, are in the P block. How we have predicted that this is in the P block, because the last electron has entered into the P subcell. Similarly, in the chlorine, last electron has entered into P subcell. Then this is the P block element. Then this is the valence electron, valence cell. Then the total number of electrons in the valence cell, that is 3. These are the P block. Then the prediction of group of that element should be used as the formula 10 plus 3. Then this is the 13. Then 13 is the group of aluminum. Similarly, for chlorine, in the valence cell, these are 7 electrons. Then for the prediction of group, the formula is used as 10 plus number of valence electron, that is 7, and this is 17. Then for the 17, the group number of chlorine is 17. Then now take example of D block elements, vanadium and copper. In the vanadium, the valence cell is this. It's my outermost electronic configuration, 4s2 and 3d 3. Then your last electron has entered into the D, then we have predicted that this is a D block element. And valence electron are total 5. Then the group of this element is what? 5. Similarly for copper, the outermost electronic configuration is 4s1 and 3d10. Then total valence electron here is 11. Then the group that we have to predict is 11. Simply. So today's video was about how the prediction of period, block and group of the element. We have discussed in detail. Now try yourself. The question is the prediction of the block, period and group to which the following elements belong. First one is sulfur, second chromium, third barium, fourth calcium, then iron, krypton, gold and bromine. This is all for today's video. Thank you very much.